Hey, microbiologists, or today I should call you hello, microscopists, because we are doing microscopy today. So, in this video, we are going to talk about different kinds of microscopes. Did you know there were different kinds of microscopes and they all function in different ways? The first kind we're going to talk about is brightfield illumination. Brightfield illumination would be the kind of microscope that we use in lab. In this kind of microscope, visible light is used to illuminate your sample. So you have a sample against a white background. You may stain your cell, or your cell needs to show up in some way. And the light that reflects off the specimen will enter the objective lens. Another kind of microscope is darkfield illumination, where light that reflects off the specimen, and that's the only light that's going to come into the objective lens. So anything that's not bouncing off this specimen is going to look dark. Your background is going to look dark. This is really nice because you don't have to stain your organism. It shows up just because it's there. So this is really good for looking at live organisms. So in our lab, we never look at live organisms. We always have to fix them and stain them. But with darkfield illumination, you can look at living organisms. So that's an important feature of this kind of microscope. Living organisms can be seen with darkfield illumination. It lets you see organisms that would be invisible with an ordinary light microscope. It lets you look at organisms that just can't hold a stain, that you're not able to stain them with any standard methods. If you have a cell that just gets messed up by staining, where it's all distorted in its shape, you can see this because you're not going to distort it. You won't be staining it. And if you have cells that are suspended in a liquid that you can't stain, you can see them very well with this type of microscopy. Our next one is fluorescence microscopy. Fluorescence microscopes are very important if you are going to be going into a diagnostic field, because fluorescence microscopy allows you to immediately know if you are dealing with a particular pathogen or not. So fluorescence is the ability of a substance to give off one wavelength of light when they have another wavelength shown at them. So you shine ultraviolet light at them and they'll glow. They'll give off visible light. The way that this works is because you have an antibody. So here's our antibodies that are tagged with fluorochromes. These fluorochromes are fluorescent. So you have all these antibodies. If the antibodies stick to something, they won't be washed off. They'll give you a glow. If the antibodies don't stick, they'll be washed off and you won't glow. So here's a bacteria and you say, I don't know. Does my patient have syphilis or not? So you have these antibodies that only stick to syphilis, and they'll stick to this. If they stick to the cell and glow, you say, yep, that's a positive sign. This patient has syphilis. If your patient doesn't have syphilis, there's nothing for the antibody to stick to. The antibody rinses off, and you go to look at your slide on the sample. You have no fluorescence because you have nothing left there. You've rinsed off the antibodies because they didn't stick. So you would say, no, my patient didn't. So here this patient has whatever disease they're looking at. And you can see it just looks like they're glowing, right? That's fluorescence. So that's a very important thing here about fluorescence. You can identify if your patient has a particular infection or not. Then let's get into the super fancy, super expensive microscopes. So electron microscopes, I have no experience using them because they're that fancy. But electron microscopes don't use visible light. They use beams of electrons. And the reason you can use this is because electrons also travel in waves, just like light beams travel in waves. But electrons have a much shorter wavelength. This little lambda here means wavelength. The electrons have a much shorter wavelength. So with that smaller wavelength, you have better resolution, up to 100,000 times better resolution. So you can see much smaller objects, even down to smaller than 0.2 micrometers. This is tiny, tiny things. So you can see viruses. You could even see DNA inside of a cell. This is fabulous that you can see things this fancy. In an electron microscope, The images are typically going to be black and white, and so you'll typically use a computer to artificially color them to see things. You can see this, how fancy this microscope is. This is no small potatoes. This is like fancy stuff. I think in our area, Ballard has some electron microscopes. There may be, I don't know. I don't know that ETSU still has one. Ballard is probably your best bet if you want to be working on an electron microscope. There's two types of electron microscopes: transmission electron microscope and scanning electron microscope. At this point in your career, I'm okay if you can't describe to me the details of these, but you know that transmission electron microscopes, scanning electron microscopes, these are both types of electron microscopy. They can see tiny detail, and they use electrons instead of light. So at this point, you can tell me, how are brightfield, darkfield, and fluorescence microscopy similar? We took out phase contrast, so don't worry about that one. And then, why do electron microscopes have greater resolution than light microscopes? Okay, my microscopists, I look forward to seeing you soon. Come back for our next lecture, where we will discuss how we stain cells in the lab. So how you can actually look at your cells in a microscope.